Today we are doing 6F, which is given one trigonometric function, we want to find another. So in example number 1, it says it is known that sine theta is equal to 2 over 5. Find all the possible values of cos theta. Using our diagram for all stations to central, we know that sine is positive because 2/5 is a positive fraction. Sine is positive in the first quadrant and the second quadrant. So theta could be here, or it could be an angle in this second quadrant over here. Now we're going to turn these into little right angle triangles. Using the one in the first quadrant, sine theta equals 2 over 5, and remember that sine theta is opposite over hypotenuse. So the 2 could be the opposite and the 5 would be the hypotenuse. Because we've got a little right angle triangle here, we can use Pythagoras' theorem to find this third side here, which I'm going to call x. So x equals square root of the hypotenuse squared minus the shorter side squared, which is 2 squared. 5 squared minus 2 squared equals 21. So that's the square root of 21. And we want to leave that exact because we need to use that to help us with the next part of our question, which is to find the possible values of cos theta. Cos theta is equal to adjacent over hypotenuse. So in this first quadrant, my adjacent is the square root of 21 that I just found, over the hypotenuse, which is 5. Okay, so that is my answer in the first quadrant. However, remember I have this triangle in the second quadrant here as well. Now the values on that triangle are all the same. This is still 2, this is still 5, and Pythagoras' theorem would be that that one there is still square root of 21. However, to find cos of theta in that second quadrant, we know that it would be negative because that is the sine quadrant. So it would be negative square root of 21 over 5 for our second quadrant solution. Okay, part B of the question says to find cos theta again if it is also known that tan theta is negative. Now, we only have solutions in the first two quadrants here. Everything is positive in the first quadrant, so I can't be talking about that solution. So it would have to be the second quadrant where sine is positive and tan is negative. So this is the solution that I want here. I'm going to write a little explanation for you. And it says because tan theta is negative, theta must be in the second quadrant. Therefore, that means that the solution that we are interested in is cos theta equals negative square root of 21 over 5. And that is what you are practicing today in exercise 6F.